Hello students, welcome to this lecture number 6 on chemical equilibrium. In this lecture we will be going to discuss the characteristics of equilibrium constant. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So far in the chemical equilibrium chapter we have discussed many topics. And equilibrium constant is very important thing in this chapter. So in this video, in this lecture, we are going to discuss the characteristics of the equilibrium constant, and there are basically 5 characteristics that we are going to discuss. The first characteristics that the equilibrium expression this is the first characteristics, first feature of the equilibrium constant, that is the equilibrium expression is only valid for those concentration terms, that is the concentration of reactants and concentration of the product, which is constant. When it is constant, the concentration of your reactant and the product, when it will be in the equilibrium. So at that time, the concentration we have to consider at that time when the reaction is in equilibrium. At that time, this concentration term will give us the expression or the constant, the actual constant of this equilibrium constant. So second thing that we need to understand, that is the second characteristics, the equilibrium concentration, equilibrium expression, equilibrium. The second characteristic is the equilibrium expression is independent of the initial concentration of the substance. That is what it tells. It tells that equilibrium constant, whatever the initial concentration we take, equilibrium constant is not going to be influenced by this. Okay? Third point is very important point, that is the equilibrium constant, equilibrium constant is temperature dependent. It temperature dependent and it is have equation. So now you understand that is a third point, third characteristic is very much important characteristic that we have to understand, that the equilibrium constant is temperature dependent and it is having a unique value for a particular reactions and it is supported by a balanced chemical equation. So that things that we are going to understand. For that, there is an equation given by Van 't Hoff. The scientist Van 't Hoff given the equation, that is the relationship between the equilibrium constant and the temperature. Van 't Hoff equation, it tells that d ln k by dt dt, that is equal to del H0 by RT square. So you can see it is the derivation of the ln k, and that is been given by this del H0 and RT square. And you know del H0 is the enthalpy change. You can say in standard enthalpy change. Enthalpy change of the reaction. Enthalpy change of the reaction. Okay. This is how you correlate the temperature with the equilibrium constant. Now, what we have to do? We have to make the integration of these two terms that is given by the Van Trost to find out the relationship between the temperature and the equilibrium constant at different temperatures. Right? Now we will go for the integration of these equations, and that will. So from this relation you can able to correlate the equilibrium constant at different temperature with the del H0, that is enthalpy change, the constant enthalpy change. Now let us see this, analyze this equation. When del H0 is 0, that is there is when the reaction is going on and there is no change of the enthalpy, means energy is neither evolved nor absorbed. At that time, if we put this figure, you will find the k log k2 by k1, that will be 0, means that is log 1. So we can see k2 is equal to k1. So when there is no change of enthalpy in the reaction, then it is independent of the temperature. Equilibrium constant is independent of the temperature. Second relation that you can see, when del H0 is positive, means it is exothermic. Del is positive means it is endothermic. When for this endothermic reaction, what we see for endothermic reaction, this minus will not be there. For this endothermic reaction, this what will happen? This will be positive value. So we can have log k2 by k1 is greater than 1. Okay. For endothermic reaction, when the energy is absorbed, then that del H0, the change in enthalpy will be there. The positive enthalpy has been increased. Then we will say del H0 is plus V positive, that is the endothermic reaction. For this, log k2 by k1 is this. So we can see k2 is greater than k1. Means as we increase the temperature, the equilibrium constant will going to increase. And for the when del G0, that is negative, means it is exothermic. When is it exothermic? When the exothermic reaction is there, at that time we will see the log k2 by k1 is equal to less than 1. Because when it is minus, this value will be minus, then k2 will be less than k1. At that time, with the temperature, increase of the temperature, the equilibrium constant is going to be decreases. So we can understand this. Now, which type of question may come, that we will now discuss. This is a question. Very interesting question. In exothermic reaction, 10 degree rise in the temperature will, option is given here, that decrease the value of K, double the value of K, not produce any change and produce the same K. For that we have to take the help of this equation that we have already discussed, that is log K2 by K1. It is given by del 0 by R is equal to T2 minus T1 by T1 T2. When it is exothermic reaction, then del H0 will be negative, and when this is negative, this quantity will be negative. So we can say log K2 by K1 is less than 1. So we can say K2 is less than K1. So which option will be correct? That decrease the value of the K will be the correct answer. So you understand, for an exothermic reaction, the decrease of the value of the K, because here there is a negative change of the enthalpy. Enthalpy is decreasing, but it is the endothermic, then it will be different. Then it will increase the value of the K. Okay, this type of question will come. Again, there is a second question that you can see, that at constant temperature, the equilibrium constant Kp for the decomposition reaction N2O4 to NO2 is expressed by Kp is equal to this. There is 4 statement is given here. You have to find out which is the truth statement. Kp increases with increase of the P. P is the pressure and X is the concentration. B. Kp increases with increase of the X. Kp increases with decrease of the X, and Kp remain constant. This you can able to understand when you see the third characteristics, that temperature dependent. Equilibrium constant is temperature dependent. It does not, in the second conclusion, second characteristic, that it does not depend on the initial concentration. So it is also not depend on the pressure. So here the Kp increases with the P, it is not a correct statement. Kp increases with the increase of X, it is also not correct, and Kp increases with the decrease of the X, it is also not correct. Correct answer is Kp remain constant. Okay, so you can understand how the characteristics of the equilibrium question may come regarding this. Okay. The fourth characteristics, the equilibrium constant of the reverse reaction is the equilibrium constant is the inverse of the equilibrium constant is reverse reaction is the inverse of the equilibrium constant for the forward reaction. Suppose this is the equation. It will have the equilibrium constant is Kc. Now the reverse reaction is this, it will have the reaction will be equilibrium constant will be 1 by Kc. Okay, and that is all for the characteristics, and we will discuss in the next things, that is the application of the equilibrium constant, in the next video. Till then, all the best and be best.